Okay, so in this unit, what we were working on was trying to figure out the value of x. And you're given an equation. And you're going to be doing a lot of this in your future math courses, right? These get more and more complicated, but the principles are still the same. Our goal was always to keep x on the side that it's on and move all the other numbers on the same side of the x to the other side. And the way we accomplished this was by doing the opposites, right? So we, like in the first example here, we split it at the equal sign, and you go, okay, our goal was to get x. So Taj, can you put that, turn that off? All right. X all by itself. In order to do that, we need to get this 3 and this 5 to the other side. So we have a choice now to make. There's two numbers that need to be moved. Which one did we move first? Emma? 5. The 5. The one that required plussing or minusing. The one without the x. And Emma, how did the 5 look like on the other side? Minus 5. It was the opposite on the other side. So we had this 5 here. We wrote down minus 5 over here. And we crossed this off because we moved it from one side to the other side. Right? And each time we do a move, we clean it up. So on the left side, we're left with a 3x. On the other side, we're left with a 9 minus 5, which was a 4. Okay? And then we go back, but we're not done until x is all by itself. So this 3 still needs to be moved away from this side. How do we move that 3 away? Right? Emma?
You divide 3.
You divide 3. Remember, we're doing the opposite. Because that's 3 times x. So you divide by 3. Because that 3 on the top gets cancelled by the 3 on the bottom. And whatever we did to one side, we did to the other. So these 3's disappeared. You're left with just the x. That was our goal. And we're left over with 4 over 3. Right? And the whole process is called isolating the variable. The variable, your letter, is isolated all by itself. Right? And now you know the value of x. That is your answer. Okay, so there's lots of questions here. I don't think we're going to do all these. I'm hoping that from my morning's class that this came back quite quickly. So we'll see how many we need to do. Okay, at the equals, split it. On the side of the variable, on the side of the letter, we got two numbers in there, 2 and a 4. Which one do we move over first? Okay. Somebody other than Emma this time. I'll come back here. Somebody else on Taylor. And how does the 4 look on the other side? Plus 4, yeah. It's minus 4 over here, so it looks like it's opposite on the other side. So you cross it off, move it to the other side. We have a 2x sitting there, and a 6 plus 4 was just a 10. Now that 2, how do we get rid of that 2? Right? What do you think, Jacob?
Divide by 2.
Yeah, it's 2 times x, so you divide by 2. And the 2's disappear. We have 10 over 2, which we simplified down to just a 5. Okay, so this question and the previous question, very similar. Right? Now, only way to make it a little bit different is throwing in decimals. It doesn't change things, right? We're still just moving numbers as we did before, right? We move the number that has the plus or minus sign first over to the other side. It becomes the opposite on the other side. So that 3.2's got to go to the other side, becomes a positive, this disappears, we clean it up. 4.1 plus 3.2, 7.3. Okay. So now, just like before, it's the number with the x that we need to get rid of. How do we get rid of that? Just like we did before. What did we do? Huh? Jacob? Divide, right? So we divide. Because it's multiplying, we divide. Okay, and the 2.5 is gone. Now, you don't want to leave your answer as a decimal. If you have decimals, this is where things change a little bit. You just do that calculation. So you grab your calculator And you go, what is 7.3 divided by 2.5? 7.3 divided by 2.5 is 2.92, right? So x is equal to 2.9. I'm gonna write down. If I don't tell you how many decimal places to give the answer to, rule of thumb, if the question has one decimal place in there in its number, give me the answer in one decimal place. Right? But I won't dock you any marks if I don't give you a condition of how many decimal places should be. Okay? Is that coming back to you, Ash? All right? So these were some of the easier ones. Right? How about this one? We split it at the equals. Which number do we move over first? We're going to go quickly through these, right? What do you guys think? What do you think, Ivan?
5.
5. How does it look like on the other side?
9 minus 5.
Yeah, 9 minus 5. Perfect. And 9 minus 5 is just 4. Okay, now we have that 2 sitting there. How do we get rid of the 2? Okay, remember, it's always the opposite we're doing. What do you think, Sartaj?
Times 2.
Times 2, right? A 2 on the bottom gets canceled by a 2 on the top. So we're multiplying by 2. And whatever we do to one side, we do to the other. So the 2's cancel out. We're left with just an x and a 4 times 2, which is an 8. Okay? All right. Let's do this one instead. Let's skip the middle one. I think you guys got this. Let's do this one instead. Okay? We split it at the equals. Which number do we move over first? Right? The 3's, the 7, or the 2.5? 2.5. Right? And it looks like the opposite on the other side. So that's positive 2.5. It goes minus 2.5 over here. Okay, and we clean that up. So 8.4 minus 2.5, we get 5.9. Okay. On the other side, this 2.5 is gone. And I'm going to rewrite this into a nicer notation. Instead of x being off to the side, I think most of you guys prefer to see the x with the numerator. So I'm going to rewrite this as 3x like this with a 7 like this. Okay? So we haven't talked about a question like this, but we've done many of these in the past. So now we have two numbers attached to the x. How do we get rid of the 3 and the 7 in one go? Who remembers this step? Ethan?
You just switch the numbers.
You switch the numbers around. Because these are multiplying, so we have to multiply and divide. So we switch the numbers around. We have a 7 on the bottom that we want to get rid of. So we have to put a 7 on the top to get rid of it. Right? So we do the same thing over here. Right? 7 on the top. And we have a 3 over here that we need to get rid of. So we're going to put a 3 on the bottom. Okay? So the 3's cancel out. The 7's cancel out. And you just put the x. You also need to put a 3 in the bottom here. Now, sometimes it looks a little weird. You do have a fraction times a number here. To help you out, you may want to go over 1. Right? So now, when we're multiplying fractions, we multiply the tops together, we multiply the bottoms together. So if you multiply the top together, we go 5.9 times 7, and we get 41.3. We multiply the bottoms together, we got 1 times 3, which is just 3. Okay. Now, you see a decimal in the number, so we don't leave it like that. We do the actual calculation. So remember, the fraction line just means to divide. So we just grab our calculator, we go 41.3 divided by 3 is 13.76666. Okay, if we want to go to one decimal place, what number do I write down?
7.
Not 7, 8. So remember, there's a 7 there, so you need to check for rounding. You look at the number after, that's 5 or bigger, tells us to round this out. So that'd be 13.8. All right. There we go. Okay. And I think that was the most straightforward stuff. And for the most situations, if a student made a mistake, it was usually just dealing with a negative sign or something like that. Right? Things got a little bit harder when we got to this kind of question. Okay? Right. And if we did the same steps as what we did before, hey, we're going to move the one with the plus sign over to the other side. That would look like minus, don't write this part down right here. Then what we have here is a fraction minus a fraction, which becomes a harder calculation to do. So instead of doing this calculation, we did a math trick and got rid of all fractions. If you're comfortable with adding, subtracting fractions, go ahead and do that. For the majority of the class, I think the goal is to get rid of the fractions. And what we did is we found common denominators. So we looked at all the denominators. We got a 4 sitting here, and a 3 sitting here, and a 4 sitting here. What is our common denominator? What number can all these numbers fit into? Cadence? 12. And what we did is then we multiplied every term by 12. Okay? And the whole goal of doing this was to get rid of the denominators. So what we did next is we went, hey, this denominator, how many times does it fit into the number we just multiplied? How many times does 4 fit into 12? Right? So how many times does 4 fit in 12? Or what is 12 divided by 4? Ethan? 3. So what we do is we cancel out the 4 and cancel out the 12 because it fits in 3 times. We simplify that down to a 3. And what we have left over is a 3 times an x, which was just a 3x. Okay? All right. Now we do the same thing for the next one. Right? We go the bottom number, denominator. How many times does it fit into the number we just multiplied? 12. Emma?
4.
Yeah. So cancel out the 3, cancel out the 12. We leave a 4 behind. Now, what number we wrote down here was the multiplication of what's left over. 4 times 2 was an 8. Okay? Now, I have 2 terms sitting there. And whenever you have 2 terms sitting there should be a plus sign or a minus sign separating them. Should there be a plus or a minus here in this situation? Plus. Right? Because you have a plus up here. And you have a 4 times a positive 2 makes a positive 8. That's where the plus came from. All right. So, last one. 4 fits into 12 how many times? We already talked about this one, right? 3. Right? So, cross out the 4, cross out the 12. Put a 3 up there. What number do I write down here? 9. We left with a 3 times a 3, which is 9. Okay, so now, very similar to what we just did. Becomes one of those questions. We got rid of the fractions. It makes it a lot easier to deal with. What number do we move over first? We split it at the equal sign. The 3 or the 8? Emma?
8.
8. How does it look like on the other side?
Minus 8.
Minus 8. All right. Gone. Then you get left with a 3x here and a 9 minus 8, which was a 1. Okay. Now we need to get rid of that 3. Right? We're not done until x is all by itself. All isolated. How do you get rid of that 3? Divide. Thank you. I think you guys are remembering this, and I don't need to do all of these questions. So x equals 1 over 3. Okay. You guys want to do another common denominator question?
Sure.
You guys? No. I think you guys got this.
I don't think we should do it.
Yes.
All right. So I'm gonna do a bracket question on the last page. Your assignment for today won't have any brackets in it. And we'll do one other question as well. Okay. So this is the stuff that we did right before we left. Right? And we said, hey, if we want to solve an equation with brackets in it, before we can do anything else, we need to get rid of those brackets. And what we did is we took the number outside the bracket and we distributed it to everything inside the brackets. We took it from the outside and we multiplied it to everything in the inside. So we took this 5 and we multiplied to the x, and we got 5 times x, which was just a 5x. Then we took this 5 and we multiplied to the next thing sitting in the brackets. And you had a 5 times a 3, which was a 15. Right? And that 5 only touches the stuff inside the brackets. The 12 is not inside the bracket, so that just stays as a 12. Okay? So now that the brackets are gone, it becomes nice and clean like the other questions. Right? Which number do we move over first? Right? The 5 over the 15. All right? Ethan? 15. And it's minus 15 on the other side. So 5x is equal to 12 minus 15. And what number do we have there? Right? What is 12 minus 15? Emma? Close. Negative 3. Right? You're taking away more than what you have. Right? So now we need to get rid of the 5, which just like before, we divide by 5. Okay? And x is equal to negative 3 over 5. Okay, so to speed things up and give you more time for your assignment, I do want to give you one other question. So cross this one out. Let's do another question here. So what if, just a reminder, it shows up on your assignment. What if the question looked like this? We did this on like the first or second day of notes in this chapter. How is this question different than other ones? Ethan?
X is on the bottom.
X is on the bottom. It needs to be moved to the top. How do we move it to the top? Ethan?
We do the opposite. Get rid of it.
Yeah, we do the opposite to get rid of it. So the x is dividing on the bottom, so we multiplied x to the top on both sides. Okay? And what this does is we cross out the x's here. And what we have left over is 4 over 7 is equal to 2x over 5. Okay? And now this is our starting point for the question, right? So we don't look on the left side to move the numbers. Typically we look on the left side, but we look on the side of the variable. That's what we're going to focus on. Now the variable in this situation is on the right hand side. So the numbers on the right hand side need to go. How do we get rid of those numbers? What do we set up? All right, so we did a question like this earlier. How do we get rid of that 2 and the 5? Sartaj?
You got to like a division of the 2 and then the times of 5.
Yep. So 2 on the top or 2 on the bottom?
2 on the bottom.
2 on the bottom, right? Because the 2 on the bottom cancels the 2 on the top. And what goes on the top?
5.
5. There we go. And you do the same thing over here. So now the 5s are gone, the 2s are gone. We're left with, on the other side, 5 times 4 on the top, which was a 20, and 2 times 7, which is a 14. Now, whenever you have your answers as fractions, you check to see if it can be reduced. Can this fraction be further reduced? Yeah, they're both even numbers, right?
Yeah.
So you divide both on bottom, top and bottom by 2. Divide this by 2, divide this by 2, right? You end up, not, no, 7, 10 over 7. 10 over 7 equals to x. Okay? All right, and we'll call